Using Python, reinforcement learning, and my knowledge about machine learning, I was able to code this spectacular Gamebot, and you can too. Keep watching the video.
Tell me that wasn't just so cool what you saw. Anyways, I'm Online Richard, and I'm going to be showing you how I coded a Cartpole Gamebot. So without further ado, let's get to it. You may be wondering what Cartpole really is. Well, as you saw previously, it was a white background, a black box, and a brown pole sticking up from it. Basically, that brown pole is the Cartpole, and the purple square at the bottom of the brown pole is its pivot point. Now, the cart has to move left and right to keep the brown pole up in the air. Now, if you were to play this game on your computer using your arrow keys or the AWSD keys, it would be very difficult to keep it up in the air as humans aren't capable of having such a fast reaction time. But computers are, and that's what I've coded this Gamebot to do.
Reinforcement learning is an area of machine learning that talks about how agents can take actions in environments so to maximize a cumulative reward. The problem, due to its generality, is studied in many other disciplines like creating game bots and controlling theory. Reinforcement learning is considered one of the three machine learning paradigms, alongside with supervised learning and unsupervised learning. Later in the video, you will see how I have used reinforcement learning to incentivize the Cartpole to gain a larger reward so that it remembers what it did last time so it can do better and better each time. Just a phenomenon of machine learning. I've started with importing some libraries. So we have the gym library, which is OpenAI's library. We have a random library, NumPy, and then tflearn, layers core, tflearn, all this stuff this is all TensorFlow. And then statistics to be able to report the statistics, collections to be able to collect this information, and time to be able to know when to reset itself. Then this part is actually harnessing the actual game. env equals gym.make, and then we have Cartpole version 0. That is the version of Cartpole that we want to use because Cartpole version 1 is slightly updated and I would need to address my code a bit. This part. So this is just defining what the game is. It talks about how when you're going to reset the game, how the game will render when you restart it up again, and what will happen when the game finishes. Now, it says here break. That's the part where you saw that it kind of stopped and then restarted up again. And then this is all preliminary stuff. Basically what it's saying is that it's harnessing all the training data done for my TensorFlow training and using that data to keep the Cartpole up. And so here, score.append, and then in brackets we have score. This is what it looks like with the score. As you can see, it has average score 200, and the score for this game was 200. So this is the 19th game I've played, and as you can see, it's a binary function using zeros and ones, and it updates us every few seconds with game number 18 at 200, and then updates us again at game number 17 at 200, and so forth. This is a really cool part of my code because it's a neural network called a deep neural network. And what a neural network does is that it filters information from one point to another in order to get the most optimal answer or the most optimal way to perform a task, which is exactly what I did in this circumstance. So as you can see here, the activation function is ReLU, and here it's softmax with an atom optimizer. Now, this neural network has input data, shape, and the input size is 1. And then what it does is it'll just return the model, and the model the model is basically the game. And this right here is our training scripts. Now, when we are training Gamebots, you need to make sure you have enough data to make sure that it knows what it's doing. This is a reinforcement learning problem because it has some data because we've harnessed the environment. Remember, env equals gym.make and then Cartpole version 0. And so this is just harnessing that information and then and the neural network is in place in order for it to get the information that is not present, because this is a reinforcement learning model. Now that you've seen how I've coded this Cartpole game, I wanted to show you some cool GitHub codes that I found and my GitHub account. So here is my GitHub account. It's https://github.com/armandmerchant, and I have about 10 repositories. So you can just go through all of them, see what you want. For this one, I'm gonna put this Cartpole equals Gamebot in the description so you guys can see it. So when I open this, you will see that I have a README, so you can always contact me or find me on LinkedIn. And I have so this gamebot.py is the code that I just showed you, and this one is the DQN solver Cartpole. So if we click on that, you will see that it defines Cartpole, and it actually uses the first version. I've used a slightly older version, but basically what this does is it'll solve any deep Q learning problems in your code by replacing it with its code. So if you couldn't figure out how to reset it using your neural network, you could import this code into your code and it should fix a problem for you. Over here in replay Cartpole, this is the experience replay code. Basically what it's saying is that every time it updates, it gets an award. So just like humans, we have to incentivize the computer. In this case, the reward is a higher score. And that's basically what we want. We want it to remember what it did wrong so that every time it improves.
Wasn't that so cool? You could do the same thing. I put the link to my code in the description so you can access it whenever you want. Hope you have a great day. I'm Armand Merchant and we'll see you in the next video.